Hello everyone, welcome to our channel Sticky Mac. So for today we have a topic of switch. So what we'll do is let's talk more on our networking device switch and without wasting much time. So let's get into our agenda what we have for today. So first of all we'll discuss what is switch and why do we need that, right? So it is very much important to understand what exactly is switch and why it was invented, or we also have other devices. So why do we need a switch, right? So that would be the first part of it, and later on we'll understand how does it fit, or where does it fit in our OSI and TCP/IP model. And moving on, we'll also try to understand various types of switches. Of course we have many types of switches in L2 itself. I'm talking about layer 2 switch, right? And moving further, we'll try to understand the exact difference between a switch and a hub. And our last point would be, in order to understand uh, switch and its working, we'll talk more about the functionality and the features of a switch, and then how it works when the new switch is brought into the network and so on, right? So this is what we have for today's class. Then, yep. So let's start with what is switch, right? So as we all know that switch is a networking device. So let's recall all the networking devices that we have. So let's say for example we have a hub, we have a repeater, right? Which works at the layer 1 device, and we have a bridge and a switch which works at the data link layer, and we have a router which works at the network layer, right? And then we have various other devices, like it could be a firewall, web application firewall, and IDS, IPS. So all these are called as networking devices because those can be interconnected, and then which can communicate with each other, and then that is how the network is built, right? So that is why we call them as networking devices, and switch is one among that. And as I rightly mentioned that today we are talking more on our L2 switch. So when I say L2, it's referenced with our OSI layer, right? So you can always go back home and then try to compare it with TCP/IP layer, right? So in OSI we have 7 layers, in TCP/IP we have 4 or 5 layers, right? So I would talk more about OSI layer. So why do I talk more about OSI layer is just OSI is used as a reference model, and then next class we'll talk more about TCP/IP, and then in-depth features of TCP/IP, right? So this is what it is, right? So this is the switch, which is a networking device. It fits into a layer 2, which is a data link layer of an OSI model, right? Open System Interconnect model. And so now let's talk about why do we need this switch, right? So let's understand that we have a OSI model. So OSI has 7 layers, right? Starting from, I mean, you can start from bottom up or a top down approach. So if you start from top down approach, application layer is your first layer, and then we have a presentation layer, and then we have a session layer, right? And then we have a transport, and then we have a network layer, and then here comes our data link, and then we have physical, right? So this is our OSI model. So now we are mainly discussing on data link layer, right? So this is where our switch fits, right? And now we already discussed very briefly that in physical layer we have let's talk about hub, and we also have repeater, right? So now if you could ask me, let's go from bottom up approach, right? We already have hub and repeater, right? So now what was the need of bringing up the new device called switch, right? So in order to understand that, So as you have already gone through the hub and the repeater in our previous class, so I will just just brief up about the difference between the repeater and the hub, with comparison of switch, and then that would actually makes the difference and then answers our first question here. So as we all know that hub is a dumb device, right? And it cannot differentiate between the incoming bits and then the incoming traffic. So that was the major disadvantage of a hub. And talking about repeater, repeater is it is a more kind of a device which amplitudes the signal, and then it helps in communicating over long distances without attenuation. So here attenuation is something that loss of power or loss of signal. So in order to prevent that, we use a repeater. But then repeater, guys, repeater also works pretty much same as the switch, but the difference or the disadvantage I would talk about of a repeater is that it cannot differentiate between one segment of a network with the another segment of a network. So what do I mean by that is let's understand that. So assume that this is your switch, right? And then you have a one segment here and then number of devices, right? You have another segment of a network here. So you can use repeater. Assume that these all segments are connected to your repeater, right? So here you can use the repeater, and then you can use it to communicate, right, within a segments. Like let's assume this device wants to communicate with this device. This can happen with the repeater, but communication with a segment 1 and the segment 2, this cannot happen. So because repeater cannot understand the different segments in a network, all it can understand is a same domain, or a same segment level of a communication, right? So this was the major disadvantage of a repeater, right? So this actually made to come up with a new device, right? So that is why we have a new device called switch. And before we get into understand more about switch, always keep this in mind that whenever we go from bottom up approach, right, like from physical layer to top application layer, whatever devices that we have whatever devices that we have always comes up with a better intelligence. So let's take an example, right? At the bottom layer we have hub and repeater. So if you compare hub and repeater with switch, switch is has a better intelligence than hub and repeater. And then let's move on to network layer. We have a router there. So router of course is very intelligent than switch. So likewise, whenever you go from bottom up to top, to the top layer, then there's a better intelligence, right? So this is all about why do we need switch and then where it fits in our OSI layer. Assuming that you have gone through our previous video of hub and a repeater, so I have just added points about hub and repeater, the advantage, the disadvantages of a hub and repeater here, and then I just compared that with a need of the hour or the need of the time, and then that is why the switch was uh, invented, and then it was being brought up into the data link layer, right? So that is the one thing that we had in our agenda. So now let's move on to the second part. So we have already discussed about it in a very brief way. So rightly here you can see that switch fits better in data link layer. This is the basic info that we have already. Now let's talk about some more additional information, right? So in physical layer, all the devices that fits into physical layer, or works in a physical layer, uh, understands only the bits, right? The hub and the repeater, whatever the packets or the traffic that comes in, it is distributed in terms of bits like zeros and ones, and then it is being transmitted over the network. So this kind of information is what we call it as mm, PDU. PDU stands for protocol data unit, right? So for every layer we have a PDUs. So for layer 1, that is a physical layer, the PDU is bits, protocol data unit, right? So all the devices here works on the bits, so that is the data there. And then talking about data link layer, for data link layer we have PDU as, you know, frames, right? And talking more about data link layer, guys, so data link layer is also subdivided into LLC, that is logical link uh, category, or the logical link layer. It should be triple L. And we also have a MAC, media access control. So these are, data link layer is internally divided into these subdomains, I would say, or subcategories, right? So our switch works mainly on media access control, right? Our device which mainly works on media access control, that is MAC address. So we also rightly know that MAC address is 48 bits, and then it is being hard coded, or let's say it is burnt on our NIC card. So here NIC stands for network interface card, to which your computer is, or any network device should possess an NIC card. Then only it is, it can connect to internet, and then can communicate with, its networking peers. So network interface card, and then this is the MAC address. MAC address is being burnt on, or hard coded on our NIC card, and our switch works on MAC addresses, right? So this is the very basic info, right? Regarding the data link layer, and about our switch. Now let's move on with, the types of switches, right? So let me quickly rub, and while I do this, let's talk more on types of switches, right? So you could, you could imagine that, let's say you are sitting in a lab, and let me draw that and explain. Okay. So assume that you are sitting in a lab, which consists of around 30 plus, or 40 plus machines, computers, where you try to work on some different technologies or things. So assume that these are the computers, right? You are sitting in a lab. Now the question is, in order to connect all these devices together, we should have a device, right? So you can use a hub there, okay? And you can use you can also use a repeater there, in an active mode or a passive mode, like we discussed about that in our previous classes. But let's not talk about those now, because they have their own disadvantages. So let's focus more on a switch, right? So we can use a switch here. So let's assume I'm using a switch, and all these devices are connected to my switches, right? So this is how all of my computers in a lab are connected to this switch. And then this is how, if you a person in sitting with system A, if he wants to ping with the system B, then he can do that by a switch, right? So the point here is, guys, now we are discussing about the types of switches, right? And this switch, okay, which can be configured, or which can be managed, okay? So in order to let's talk about, if I want to make my switch understand about the computer A or computer B or C or D, whatever it is, right, about my whole network in a lab. So what do? I configure my switch. So all the switches which can be configured are called as manageable switches, right? So this is the first type of switch that we have. Now let's talk about second type, unmanaged switches. So unmanaged is nothing, but it's kind of a plug and play. So you might know about an RJ45 cable, right? So which is connected to your system at the one end, and the other end you just plug in into a port uh, below your desk, or anywhere anywhere which it is located at, like let's say at the wall or below your desk or whatever it is. You just take this RJ45 cable, assume this is a port, and then you just plug it here, right? This is just kind of a plug and play, and there is no configuration needed here, and you cannot also configure, right? So this we call it as an unmanaged switch, right? It's just kind of a plug and play, and all these unmanaged switches are internally connected to our managed switch. This is how we manage devices in our networking lab, right? There's a one switch, which is kind of a management console to which all the unmanaged switches are connected, and to all unmanaged switches, your computers are connected, right? So this is how the network is being enabled, and this is how you can communicate. And these are the two types of switches that we have in L2 layer, that is data link layer, guys. So we also have a L3 switch that fits into a network layer. So we will talk about layer 3 network in our next class, right? So moving on, now we have understood, what is switch and why do we need that? Where does it fit in our OSI or a TCP/IP model? And what are the various types of switches that we have in a data link layer, right? Now let's move on to switch versus hub. So before we talk about how switch works, so I would let you know, or just brief on about how a hub works, and then we'll try to interconnect this with our switch, and then this is how you can better understand the difference between hub and a switch. And then, as I also mentioned that if you could remember, right, in in our today's class, that whenever you go from a bottom up approach, the intelligence of our devices is increases, right? So in order to understand our fourth point, that is switch and hub, so I would talk about a scenario here. So let's see how a hub works in a network. So this is the pre-drawn diagram that I have in order to save our time in today's class. So this is the source, this is the destination that we have here, right? And then we have four devices, and guys, this is our hub, right? So now let's assume, as we have already marked our source and destination, A wants to send a packet to B, right? So as we all know, this is a layer 1 device, right? Let's not use the word packet, let's use traffic, or kind of a bits, right? So I'll say if A sends a packet, right, it would be internally you know converted in from packet to segments, bits, I would say protocol data units of layer 1 is bits, so internally it would be converted to bits. So this is the packet that is wanna send to D, right? When this packet arrives at the port 1, right, hub, as we all know, this is not an intelligent device, this is a dumb device in a networking that we have. So it doesn't understand any of those addresses. So all it does is it just broadcast the packet to various the ports that all the machines that are connected to. So when I say that, if this packet arrives at a port 1, what does the hub do is it just forwards that packet to you know port 2, 3, 4, 5, and then 10, 9, all the ports, right? Except the incoming port, guys. Always remember this, right? Except the port 1, hub, or any other devices like the repeater switch, and usually router doesn't broadcast the packet. So all these devices from layer 1 and layer 2 broadcast the packets to all the ports except the incoming port. Here incoming port would be port 1, so this would be our incoming port. For this incoming port, the packet or the frame wouldn't be broadcasted, but rest to rest of the ports it would be broadcasted. And this is how a device or a system C would also able to see a packet that the A has sent. Of course, D would see that because D is our intended destination, and B would also see our packet. So this was okay to some extent where we don't require our security feature, and where we doesn't care much about the various security features of our communication. So when I say security features, in information security, we have something called as CIA, right? CIA tried. So C stands for confidentiality, and this stands for integrity, and this stands for availability, right? This is something we have in our information security, and these three things is what makes a proper what I would say is properly built a network model wherein we can prevent all the attacks, and prevent the attacks, and then prevent the data breaches. And these three principles would help us understand these scenarios more better, right? So I would say these three are the kind of pillars of an information security where everyone should more focus upon, right? So in our hub case, so what feature do you think it violates, right? We have three features, that is confidentiality, integrity, and availability, right? So I would say three of them would also be impacted, but the kind of a parameter that impacts here would be confidentiality, because the packet that I have sent can be seen by all the others. And saying that integrity can also be impacted because anyone sitting in between, from between the source and destination can uh, get the packet because of the functionality of a hub, and then he can make the changes, and then he can forward it to others. Availability, then of course he can bring the hub down, right? So this is how a hub works, guys, right? So now let's talk about a switch. Now let's understand what makes switch more intelligent than a hub, and then why this is our topic of the day, right? So we already know that hub is not an intelligent device, it's a dumb device, it just broadcasts the packets except the incoming one. So now let's talk about switch. So the scenario that I have taken here is, so first I would make you understand how a brand new switch works. Let's say I have gone to market, I have brought a switch, and then I have just connected to, I have connected all my systems to it, and then we'll start from there, right? We'll start from there, we'll try to understand how switch works. There is no configuration that is being made, right, except the name of a switch and so on, but nothing related to source, destination, machines, you know the forwarding table, the switching table, anything, right? So as it's a brand new switch, all the data is being flushed out, of course, right? It's a new one, we don't have anything. And now let's understand how switch helps us in communicating between a source and a destination, and how exactly it sees the packet, and then how intelligently it makes the decision, right? The decision is very important. So let's assume again, we'll have A as our source. This is a switch, guys, and let's assume now C as our destination, right? And then of course all the switches or all the network devices comes up with ports which ranges from the powers of two. Let's say device can be of two ports, four, and then 6, 8, 16, 32, 64, 128, right? So usually switches comes with 8, 16, 32 ports, right? So what you see in the diagram is of course wrong. I have just made it for an example, right? So let's assume that this is a brand new switch. There is no configuration data. Everything is being flushed out. It's new, and we have a source and destination that is being marked. And let's take the same scenario. A wants to send a packet to, you know, uh, C, which is our destination here. So before we understand that, when it comes to our data link layer frame, right? In data link layer, what is the protocol data unit that we had? We talked about here, right? PDU is frames, right? So for data link layer, we have a frames. In frames, we have a MAC addresses, right? We don't have IP address because switch layer to switches doesn't understand IP addresses. So what does the frame layer to frame has, right? The information that it has is the source port, the source MAC address, which I mentioned that MAC address has uh, 48 bits, and then I think I rubbed it. Yeah, but it's okay. MAC address has 48 bits, and then it's burnt on the NIC card. So saying that, let's move on. So we have a destination port and a destination MAC. So this is usually kind of an information that is present. This is not it, but we also have other set of informations, right? Frame sequence set identifier and so on. So let's not get into that. Let's stick to our scenario and then try to understand how switch makes an intelligent decision and then tries to switch the packet from source to destination. So we already know what information is present in every frames. Now, as our source A sends the frame, it comes to port 1 of a switch, and then switch sees that frame and then try to look for an information. So when the port arrives at when the frame arrives at a port 1 of a switch sees that, okay, as the frame has arrived at the port 1, I would assume that A is being connected to, A is being connected to port 1, right? This is what it thinks. And then let's move on. So as I already mentioned, every device knows its MAC address because MAC address is hard coded or burnt on NIC card, and every device in a network should have NIC card, and without NIC card nothing can work, right? You cannot communicate in a network, you cannot connect to a network. So every device knows its MAC addresses. So here source MAC address would be MAC address of our system A, right? This is already present in a frame, switch takes care of that, and then it writes in a table. So before we talk about the information, so guys, switches maintain a table called content addressable memory table, CAM table. And as I mentioned, it tries to maintain the state of all this information, right? So this is how it first stores all the information, and based upon this information it tries to make a wise decision. So okay, we were at source MAC, so let's assume the MAC address. Of course I cannot fit the 48 bits into this small box here, so I would mark it as XXX, right? Just for an example here. So we already know, uh, I mean, when I say we, it's a switch. So switch already knows A is being connected to 1 because this is the incoming port, right? And then the source MAC, which is already present in a frame, and then destination port. Even A, which is our source doesn't know to which port our destination is connected to. And as this is a brand new switch, our switch also doesn't know to which port which machines are connected to, because as I mentioned in earlier, right, this is a brand new switch. I have not configured anything, I just connected my devices. So even my source machine and even my switch doesn't know to which port our destination is connected to. So this column would be empty, and then it checks for the next information, destination MAC. Of course it is present in the frame, so let's assume that as y and y, right? This is all we have when the packet arrives from source to switch. Now what does switch do? Switch, as it doesn't know to which port our destination machine is connected to. It cannot send a packet directly to our destination. So what it does, it broadcasts. So understand one thing, guys, switch doesn't broadcast all the packets. All it does is, it broadcasts a very initial frame, right? So for which it doesn't have the information related to all the machines that those are connected to its ports. So when it doesn't have such information, it forwards or it broadcasts the frames to all the ports except the incoming port, right? So again it is being sent to all the ports, and then every machine would receive this packet and show our destination, which is the intended thing. And now once the packet is being received by our destination, which is C, it sees that, oh, my name is already present. So when I say name here, it's the destination MAC. Destination MAC here is YYY, which is the name of our system C. Then what C thinks is, oh, my name is already present here, then I think this packet was sent for me. So I don't see the destination port here. I also see as a source port and source MAC. What it does is, now it sends a packet back to a switch. Now let's try to understand from the perspective of C, right? For C, when it sends a packet back to switch, the source port would be 5, right? And then when the packet now comes to the switch, right? Now switch would understand, oh, now switch, sorry, the system C is being connected to port 5, right? Now the source MAC here would be, right, YYY. As I already mentioned, every machine knows its MAC addresses. So here the source MAC would change from XXX to YYY because the source machine now here is C, not A. When the source is A, the source MAC address would be XXX. When the source machine is C, the MAC address would be YYY, right? And then destination port. For C, the destination port would be 1 because this was the source port in our initial packet, right? It just interchanges everything, right? So here the destination port would be 1 because A is connected to 1 and this packet was sent from A to C. That is why we here, now it's our job to reply back to C. So the destination port would be 1 to which our source or a system A is connected to. Destination MAC just reverse it with the source MAC because now we are sending a packet to a system A, right? So now we should write the information related to system A. So to which port our system A is connected to? It is connected to port 1. Now what is the MAC address of a system A? We already know that it's XXX, right? And then this packet is sent. Now what switch does is, it writes all this information in its packet, and then it rightly knows that to which port A is connected to which port C is connected to. Now it can initiate communication between, right, A and C without any delays, right? So now whatever the packet might come, the next packet, it would easily populate. It can easily understand to which port C is connected to, what is its source machine, source MAC, and what would be the destination MAC, everything, right? But let's assume if now the A sends a packet to B, right? So again our A is connected, our source port become 1, source MAC is XXX, destination port we don't know because switch doesn't know to which port device B is connected to. And the important fact to remember here is, whenever switch boots up or whenever the it's a brand new switch, even switch doesn't know to which ports the machines are connected to until and unless those machines sends a packet to a switch, tries to establish a communication with a switch. Till that point, switch doesn't know or cannot understand to which port the machines are connected to. When a machine sends a packet to switch, then only it knows or it come to know that to which port her machine is connected. So right now in this case, switch doesn't know to which port B is connected to. It would be, you know, it'd be empty. Destination MAC would be, let's say here ZZZ, and then the packet again would be broadcasted because switch doesn't know. Now the packet would be broadcasted to all the ports except port 5, right? Because now we know that port 5 is with C, right? So the switch doesn't send a broadcast message to port 5 because switch already knows which machine is connected to C, and that MAC address is not same as the MAC address that is being present in this frame. So it would not send a broadcast message to port 5. It would not send a broadcast message to port 1 because that is being an incoming port, right? Inbound port. So it would send broadcast to 2, 3, 4, 10, 9, 8, 7, and 6 ports, right? All the remaining ports except 5 and 1. And then again the B would receive that packet, and then the second step would repeat, right? And then when the B responds to that packet, right, then switch would understand, okay, B is connected to port 6, and then the source MAC would be ZZZ, destination port. We are replying to system A, and then system A is connected to port 1, and what is the MAC address of a system A? That is XXX. So now the whole table is complete, and now any device can communicate with each other because switch knows to which port system is being connected to, right? So this is how a switch builds a table called content addressable memory. So every 30 seconds the table is updated, right, with the help of an protocols called ARP. So this table is being updated, right? What do you mean by ARP and RARP? ARP stands for address resolution protocol, where you convert IP to MAC. This is for ARP protocol. Now for RARP, this is slightly beyond our today's class, but it's okay. You convert MAC to IP, right? So this is how this table is being built, and then this is how switch makes an intelligent decision to which machine the frame should be forwarded to. So in this case there is no violation of our CIA, right, confidentiality, integrity, and availability. There are ways to attack a switch and then try to modify this table, right? We call it as ARP spoofing. Sorry for that. We call it as ARP spoofing, where you try to spoof the MAC address of any device, right? Or you could also call it as poisoning, where you try to modify the table, right? So this is how our switch works, and this is how the switch is different from our hub, right? So this was our, sorry for that, this was our fifth point, and now I think we completed all the 5 points. We touched upon what is switch and why do we need it, where it fits in OSI, TCP/IP, types of switch versus hub, and working of a switch. So always try to understand networking in a practical way, because this is a practical subject. Always try to relate this to more realistic examples, right? So then only you can understand the concepts in a better way. It's not a theoretical subject, so we cannot come here with a deck of a slides and then try to learn more about the networking, right? So networking is a practical subject, so we should understand it in a more practical way, right? So I would stop here, and that's it for today's class, guys. Thank you.